Section 6.4, we're going to look at solving some trig equations. So it says solving using known values. In the last chapter, we learned that sine and cosine values are commonly encountered angles. We can use these to solve sine and cosine equations involving these common angles. So I'm going to show you how this works out. It says solve sine theta equal to 1/2 for all possible values of theta. Notice it does not restrict any domains. It just says all possible values of theta. So let's consider where 1/2 occurs. According to your unit circle, 1/2 occurs over here when we have this angle. This ordered pair is equal to the square root of 3 over 2 comma 1/2. But remember, the unit circle is symmetrical, so it also occurs here at this one. This is where negative square root of 3 over 2 occurs 1/2. And so this is the value of pi over 6. Can't write a 6, sorry. Pi over 6. And this is at the value of 5 pi over 6, starting here and ending here on the terminal side. So I know that theta has to be equal to pi over 6, and theta has to be equal to 5 pi over 6, because all the other angles don't have a positive 1/2 as that y value. But I want all possible values. If you consider the period of sine, it cycles every 2 pi. So with this, I'm going to say plus 2 pi. So that means if I were to start here and loop around plus 2 pi, I would end back up here. It was just making a revolution. And I could do that again, and I can make another revolution and in here. So I could do 2 pi and add it on again. But instead of doing that multiple times and writing all these down, I'm just going to say k, where k is an integer. And we sometimes say integer, it kind of looks like a double Z. The same thing is going to be true for 5 pi over 6. We could add plus 2 pi, and again, we could keep circling around, so that would be k. And we would say where k is an integer, but again, we could shorten integer as this kind of double Z looking. And that would be all the possible values where this would occur. Now look at what is happening graphically and why we have to do all these possible values. If I'm going to know where my sine graph, drawn in black, intersects my 1/2, drawn on the red dotted line, you can see right here is my pi over 6. And then right here is my 5 pi over 6. And then if I add 2 pi to pi over 6, here is pi over 6 plus 2 pi. And here is 5 pi over 6 plus 2 pi. And so that gave me all those values, and you just keep on adding 2 pi. Now if I subtract 2 pi, you start to begin to get these values down here. So just kind of interesting that based off that first and second quadrant on our unit circle, we're able to get 2 values, and then adding 2 pi repeatedly to them gives us all possible values. And so this would be your final answer for all the possible values of sine. Looking at the next example, it says a circle of radius 5 square root of 2 intersects the line x equals -5 at 2 points. Find the angle theta on the interval from 0 to 2 pi where the circle and line intersect. So let's figure out what we have here. It says a circle of radius 5 square roots of 2. So that means starting here and moving over, that's our radius, that's 5 square roots of 2. Intersects the line x equals -5. So here's your x equals -5. So again, from here to this point, so any point on your circle to your center is 5 square roots of 2. Same thing to this point, 5 square roots of 2. There's 2 points. There they are. Find the angle theta where the circle and line intersect. And so what I want to do is I want to find this angle of theta. So think about what you know. We know that this x value is -5. And so if you remember, we had a formula for x's that was r cosine of theta. And I like that one because I know my x value, it was given. I know my radius, it was given. And so this gives me a way to solve for theta. And so this would be x is -5 equal to my radius, 5 square roots of 2 cosine theta. divide both sides by 5 square roots of 2. So that gives me -1 over the square root of 2 equal to cosine theta. And consider that situation. If you rationalize that radical to remove it out of the denominator, that gives you negative square root of 2 over 2 equal to cosine theta. And we know, based off your unit circle, that if we come over here, think about your negatives and positives on your unit circle. Negative is in the quadrant 2 and 3. Cosine is your x value, so I want these two angles. And we know that this occurs at 3 pi over 4. And then we know that occurs at 5 pi over 4 because this is just reflected. And so theta would be equal to 3 pi over 4 and 5 pi over 4. It makes sense I've got two answers because here would be my 3 pi over 4, and then when we drop down here would be my 5 pi over 4. So unit circle and our equation we have created of x equal to r cosine theta leads us to figure out what this angle is. Let's do another one. It says the depth of water at a dock rises and falls with the tide following the equation, and it gives us an equation. Where t is measured in hours after midnight, a boat requires a depth of 9 feet to tie up at the dock. Between what times will the depth be 9 feet? So what time we are trying to solve for this little t right here. So let's consider what our equation is. Our equation is f of t. T is measured in hours after midnight, and the depth is what it's equal to. So if I take my equation, f of t equal to 4 sine of pi over 12t. Now let's not mess up that sign right there. We can see that that is plus 7. We're going to take our depth of 9 feet and sub it here for what f of t is equal for, and then we're going to solve it. So this gives me 4 sine of pi over 12t plus 7. So I'm going to subtract 7 from both sides. That gives me 2 equal to 4 sine of pi over 12t. Divide by 4. So 1/2 sine of pi over 12t. Now, I'm not sure where pi over 12t is equal to 1/2. But what I do know is, let me create another letter and let's let u equal pi 12t. So let's consider 1/2, and I'm going to sub this whole thing for u, is equal to sine of u. We do know where our sine function is equal to 1/2. And so if we were to draw this angle here, where is 1/2 going to be in our sine? And that occurs at pi over 6. The rest of that order pair is here. We know from our unit circle it reflects over here, and so at 5 pi over 6, same order pair, you have that 1/2, it just negative here, not concerned with that right now. And so I can see that u would be equal to either 5 pi over 6 or pi over 6. So I'm going to take that information and come back over here, and I'm going to say, okay, let's let our u be pi over 6 equal to pi over 12t. And so if I divide both sides by pi over 12, that would give me t equal to, divide both sides, t is equal to 2. And then if I also take my other value of 5 pi over 6 and equal it out to pi over 12t, and I solve for t, this gives me another value of t equal to 10. Now, this says between what times will the depth be at 9 feet? Now, this is going to occur a couple of times, and so I need to write it as all possible values. So I would say t is equal to 2 plus 24k, because we have 24-hour time periods, and then 10 plus 24k, because we have 24-hour time periods. So every day, 2 and 10 plus 24 hours is going to give us when the depth is 9 feet. because it's cycling through just like your sine function. Let's look at another situation. It says find all the solutions to sine theta equal to 0.8. So I'm going to take sine of theta equal to 0.8, and I'm going to go ahead and arc function both sides. So if I arc sine both sides, I get theta to be sine to the -1 of 0.8, or arc sine, whichever version. And if I go in here and I say, okay, well, in radians, I type that in because it's not something that's on my unit circle. That gives me theta to be equal to 0.927. Find all solutions, so I need to say plus 2 pi k like we did earlier. Now, if 0.927 is my angle, 0.927, I know that that angle reflects this direction, and it has the same sine values like we saw in the previous problem. And so what I need to do is I need to figure out what that value is. So from here all the way around is equal to pi, so I'm going to say pi, the whole thing, minus that 0.927, just subtracting out this piece here, and I can get the angle over here. This would be equal to 2.214. So my other theta would be 2.214 plus 2 pi k, and that's what I have in radians. Now if I do the same thing in degrees and I do arc sine of 0.8 and we move to degrees, again you need to make sure your calculator's in the right function. This would be theta equal to 53.130 degrees. Now we're going to circle around 30 degrees, so it would be we're going to circle around 360 degrees, so 360 degree K. And then same situation as before, I'm going to take 180 degrees and subtract that number to figure out the other angle. And so that would give me 126.87 degrees. But if you start rotating it around by 360, you get all your other solutions. So kind of interesting on that one where it wasn't on your unit circle. And I want to show you how that works out in degrees and radians. Two more. It says find all the solutions to 3 cosine x plus 4 equal to 2 on the interval from 0 to 2 pi. Let's look at this and see what we can do. So we have the equation 3 cosine of x plus 4 equal to 2. Let's isolate that cosine. So minus 4. So it gives me 3 cosine x equal to -2, divide by 3. And I have cosine x equal to -2/3. Now, -2/3 is not on my unit circle, so I'm going to use the inverse function on both sides to work with that. So that gives me x equal to the cosine or arc cosine of 2/3. Now I'm going to do this one in radians, so go in your calculator and type in arc cosine of 2/3, and that gives you an approximate value of 2.301 radians. But again, consider what's going on here. If that is an angle of 2.301, that would be here. It reflects down this way, so I would have another angle here. And so to get to that, I would need to move this direction, -2.301. And so if I take and I do 2 pi minus 2.301, that gives me this angle here, which is equal to 3.982 radians. So when you're working these problems, don't get carried away with all the solving and forget that you have a second answer in there. Let's do one with sine. Now on this one with sine, what I want to do is I want to make a substitution now versus at the end like we did the previous one. So for pi over t, let's call that u. So it gives me 3 sine of u equal to -2. I'm going to isolate that sign. That gives me sine of u equal to -2. And then I'm going to do my arc function. So u would be equal to the arc sine of 2/3. Again, I'm going to go in here to my radians. I'm going to type that in, and that gives me u to approximately be -0.730. Now, I'm going to take that and consider and make my two equations, or my two angles here. So that would be negative 0.730. And we know that that can reflect this direction and come down 0.730. So what I need to do is I need to come all the way around and find this angle. And so that would be 2 pi minus 0.730. Excuse me, got ahead of myself. Pi plus 0.730, because we're going to move pi and then add a little 0.730, and that's equal to 3.87 plus 2 pi k. Now our other one is going to occur when we loop around, because I want my positive ones. If I went all the way to here and took out that's what I was trying to write a minute ago. So that would be 2 pi minus 0.730, and so that gives me 5.55 plus 2 pi k, again, looping around. Now that answers u. And so what we have to do is convert this back to our t's, and we said that u was equal to pi t. And so I'm going to say pi t is going to be equal to my first answer, 3.87 plus 2 pi k. So if I divide everything by pi, it gives me t to be equal to 1.23 plus 2k. Just dividing each of those by pi. Same thing is going to be true here with the other one. So pi t is equal to 5.55 plus 2 pi k. Divide both sides by pi. So it gives me t equal to 1.77 plus 2k. And so pretty neat how all that's working out here as we work in this section. Just you need to go slow and process each piece as you go. If you have any additional questions, let me know.